Welcome to Calc Chats 43. Today we're going to be discussing how to find the arc length. That is, how to find the length of any given smooth curve. In Algebra 1, Algebra 2, and in geometry, you might have been asked to find the distance between 2 points on a coordinate plane. And so A is 1, 1, let's say, B is 8, 6. We could use either the idea of Pythagorean theorem or we could use the distance formula, but we were able to find the length of that line. The issue is that in calculus now, we're dealing with curves that are not straight. And so it would be super difficult to find the length of each individual segment of this curve as a straight line and add them up. But that's kind of what we have the integral for. And so we don't have to do it individually. We can take an integral, and that is going to help us to find each of those little segments' lengths, and so the length of the entire arc. And in order to find this length, the big important fact that we need to remember is that it has to be a smooth curve. And what this means is it has to have a continuous derivative. So if I cannot find the derivative of the function at every given point on the interval I'm looking for the length of, I cannot find the length. So if I was given something like the cube root function at x equals 0, that's a problem area. I cannot find the length at x equals 0, and so unfortunately I cannot take the length of this curve from, let's say, -1 to +1. I can't find that length. I have no idea because it does not have a continuous derivative. And so that's going to be very important to keep in mind kind of as we're working through these problems. So here's our formula for arc length. It is the integral from a to b of 1 plus the derivative of dy dx squared, all under the square root, and we integrate that with respect to x. And this is for a smooth function y on the continuous interval from a to b. Again, it's important that we have that derivative on every single point, including the endpoints. So here we're given, this is the curve. I kind of ran out of room to write it, but we're given the curve y equals 4 square root of 3 over 2. Oops, I'm sorry, this should be 4, I wrote this wrong. 4 root 2 over 3, there we go. 4 root 2 over 3, x to the 3 halves minus 1. And we're asked to find the length on the interval from 0 to 1. And so first, we need to determine, is this continuous on the interval? And it definitely is continuous on the interval from 0 to 1. If we think about kind of the square root function, there's no real gaps on the interval that we're looking at. And so what we need to do next is we need to find its derivative. So when we take the derivative, we get 4 root 2 over 3 times 3 halves times x to the 1 half. Remember, our derivative skills, not our integral skills. And this simplifies to 2 root 2 x to the 1 half. And so now I can just plug this in my handy dandy length formula. So the length from 0 to 1 of 1 plus 2 root 2 x to the 1 half squared dx. And for right now, I'm just focused that we can set up the integral, and then we'll kind of have some practice to integrate in class. So if you want to try to integrate this by hand, you can, but we get that this just ends up being 13 over 6. So if you integrate it and you evaluate it, you should get 13 over 6. So now we're asked to find the length of the curve. This is a slightly different function, y equals x cubed between -2 and 2. So this is a DIY. So go ahead, try it on your own, see if you can kind of figure it out. Again, it's a pretty basic, straightforward problem, but go ahead, pause, and try it on your own. All right, so your work for this one should look something similar to this. We know it's continuous. And it's differentiable at every point. And so all we need is to find the derivative, and we get that's 3x squared. and then we take the integral of the square root of 1 plus 3x squared, all of that squared with respect to x. And this is one that you would have to use a calculator for. You wouldn't be able to integrate this by hand, and so you'll get a decimal 17.26. So this is the lesson. This is it for arc length. Please make sure that you come to class with any questions that you have, any things that are confusing, because we are going to use this idea kind of going forward when we're dealing with parametric equations, so we need to make sure that we understand it fully now. So thanks for watching, and please make sure to like and subscribe.